TerraCurl will help us to bring everything into Terraform, whichever has or whatever has an API. And to present that, here's the maker of TerraCurl and HashiCorp developer advocate, Rob Barnes.
Thank you. Appreciated. Awesome. So I kind of got a feel from the last talk of some of you have used Terraform, but just to kind of satisfy that fully, how many people here are using Terraform or have used Terraform in the past? Okay, so that's pretty much, that's everyone, basically. Okay, cool. What are you using Terraform for? Is anyone using it for any of the big clouds, Azure, AWS, GCP? Yeah? What's the most popular cloud here in this room? Don't all fight now. Okay, so I actually wrote this presentation for a bunch of Microsoft engineers, so you'll have to forgive me. I have written this around Azure. Doesn't make a difference. The same thing applies to anything with an API, right? Now, Terraform itself, as you know, it's great. You know, I have a set of challenges that I need to solve. I need some infrastructure to solve those challenges there. And I don't really care how I get that infrastructure. I just know it needs to be in this state. So we have Terraform and we just express ourselves, right? It's fantastic. And that's why, as a developer advocate, when we do big demos, like if any of you have ever attended a HashiCorp before, my team is normally responsible for some of the big keynote demos. And Terraform is the natural choice in terms of the infrastructure that powers some of the things. We've done amazing things, like we've put our tools inside Minecraft worlds, for example, and you can actually interact with Nomad servers or Vault servers inside the Minecraft world, and it's minting real secrets or identities. And these things take a lot of like brains and more importantly, compute, right? So we did a demo a few years ago at HashiCorp. It's for another tool that I built, which I'm happy to come back another time and give a demo on that. And it relied heavily, the demo itself, on having a certain feature within Grafana. Is everyone familiar with Grafana here? Yeah. Okay. So Grafana, fantastically, has a Terraform provider as well. So we were like, great, let's do what we're doing. But unfortunately, the feature that we needed in Grafana has the API exposed, but it's not in the actual Grafana Terraform provider. So that was a problem. So we needed to get around this. I think at the time when we ran into this problem, we had less than 48 hours before we were going to be live on stage doing this thing in front of thousands of people, right? So we had to get around this problem, and we did the craziest hacks here. Now, seeing as everyone uses Terraform, I'm going to give you a few guesses as to what you think that hack was. Any guesses?
You wrote custom script in Terraform, new Terraform file to call the, yeah.
Round of applause.
Because that kind of thing was short for time, yeah.
It's ugly, right? So we did it, and you know, it worked. Loads of people actually went into the demo environment and tested it out and had a play around and so on and so forth. It was great. But after that, I kind of knew we were going to run into this problem again. And hacks is never going to be a sustainable way of doing things, right? So I decided I was going to try and find a way to solve this problem in a bit more permanent sort of manner. So I went looking for something that met all my needs, and unfortunately at the time I couldn't find anything out there that would do what I needed to do. So I decided I was going to build the solution if I cannot find it, right? So I haven't actually formally introduced myself. So I'm Rob Barnes, a developer advocate at HashiCorp. My actual focus is security, right? I'm mainly a security software engineer. But I do quite a bit of infrastructure as well because the two go hand in hand. There's my Twitter handle there, though you'll barely see any tweets from me these days. I'm not really on social media that much. But if you do have questions, do feel free to reach out to me. I'm mainly on LinkedIn under the same alias as well, so I'm always happy to speak to people offline as well, right? But this isn't about me. This is about TerraCurl and how we can help you solve some of these Terraform problems that you have, right? So let's focus on this now. So I said that we built this slide deck for a bunch of Microsoft engineers, right? Now, Azure has a few providers. They have the Azure RM provider. They have, I think they're calling it Azure AD provider, and they have another one which I cannot even remember what it's called, right? It's complicated in a Microsoft landscape. We're going to talk about the Azure RM provider today. And in their GitHub repo, I'm going to throw it out there. How many open issues do you think they have there? And this is just guesswork. Just shout out any guesses that you have. Open issues on the Azure RM GitHub repo. Go.
100?
Who said 100? Okay, you are wrong.
2000, I said.
2000.
50?
Who said, what was that, 50? 15,000?
Yeah.
Okay.
I'm an AWS guy, so I'm just...
I mean, to be fair, if you've used it before, you would expect a lot of issues. We'll just leave it at that. That's my politically honest answer. At the time of authoring this presentation, the number stands at almost 3,000 open issues. You were the closest. I wish I brought a prize now, you know. So let's kind of break this down, right? So 2,896 issues on the GitHub repo. And we can break this down into sort of different categories, right? So the labels that are put on these things is how we'll categorize them. So of that big number there, we have 1,209 of them have the enhancement label on them. So the enhancement label basically means that the resource or the data source already exists, but it doesn't do the thing that the person who's opened the issue needs it to do, or it doesn't expose something. Maybe a bit similar to what we ran into with Grafana, right? Maybe a little bit different, actually, to be fair. It's probably a bad example. But the resource or data source exists. Maybe it doesn't expose the data in the response or something like that. Or maybe it doesn't expose a certain configuration parameter, right? So it needs some enhancing for this person to get the value they need out of it. 128 of them were new resource labels. Now, this is probably a better comparison to our example with Grafana, right? The API exists, but the resource did not, right? So, you know, these things in Microsoft, the way that API evolves so quickly, and I've been on the receiving end of this many times over the years, you know, it's inevitable this is going to happen, right? So 128 new resource requests, and 61 new data source requests. Very similar to resources, it's just they need a data source, right? So, in general, the challenges that we run into when we're authoring Terraform, especially around providers, is, like we've already established, sometimes it lacks support for the thing that you need, whether it's a data source or a resource, right? But the one that I run into probably more than anything else is that the provider API doesn't have a good way of telling Terraform what done looks like. Now, I'll give you an example of that. Let's just say that I use some Terraform to deploy a virtual machine, and as part of that Terraform, there's cloud init scripts in there, which is going to, I don't know, like install Vault or something like that, right? Now, once the VM is deployed, once the cloud init script has finished deploying, Vault is not ready to accept connections and start serving secrets, right? There is a few things that need to be done. But Microsoft API doesn't know that. All it knows is they wanted this VM in this state here, and they wanted this cloud init script to run on that VM. It's done those things. So as far as Microsoft is concerned, it's done, right? But in my mind, it's not done, because maybe, like, if it was Postgres, for example, it takes a while before it's ready to start accepting connections, right? So we need ways to be able to report what our version of done looks like. And natively in Terraform providers, it doesn't really do a good job of that, because it's not their job. That's the reality of the situation, right? The third thing that comes up, and it doesn't come up as much these days, but it still comes up sometimes, is the provider does not support lazy instantiation. Does anyone know what I mean by that? Let's hear from you.
Lazy instantiation.
Yes.
I am waiting asynchronously on the provider to the plugin in my Terraform to report back in logs that the status of the task I'm giving it.
Not quite. Not quite. So there are some providers that, and I understand why it was like this in the early days, right? There are some providers that when you give it the provider config, for example, so you give it like an IP address or some sort of URL and a token, it expects those things to work at plan time, right?
Okay.
Now that's not lazy instantiation, right?
You give it and you wait to show in the statistics.
Yeah, so basically, lazy instantiation would mean that at plan time, if the IP address and maybe the password of whatever the configuration details are needed for that provider, if they are not known at plan time, but they will be known later on in the run because it's dependent on other resources provisioning, like a VM, like an IP address, a public IP address or something like that. Lazy instantiation means that, okay, we're not actually going to instantiate that provider until we actually need to run the resources for that. And that's the best way to build providers now, right? There were a lot of providers before that did not build that way. And one of the providers that I run into a lot, this issue, is one of our own providers, the Vault provider. Though it looks like it's getting a lot better now. But before, if you didn't have Vault's IP address, you didn't have a token or some sort of authentication for Terraform, it wasn't going to work, you know? So you can't, in your same workspace, provision the infrastructure for Vault and then configure Vault in the same workspace. You almost had to do two separate workspaces, right? So lazy instantiation was a big one that we run into. The obvious ones are, you know, there's a bug in a resource or the data source. This happens a lot with Microsoft. I don't know about the other clouds, but yeah, I can say with Microsoft for sure. I've been on the receiving end of that. Or the target API does not have a provider, right? Which is common for smaller platforms who are maybe new into market spaces, right? So these are some of the challenges that we run into, right? So these things coupled with my experience with my team building our demo for HashiCorp is why I decided to build TerraCurl, right? But what even is TerraCurl? Like, what does that mean? Well, I know what it is, but you know, in this AI age, I kind of thought to myself, let me ask ChatGPT if it knows this thing that I created, right? And this was the answer it came up with, right? I'll just read the first sentence from this. TerraCurl is a utility Terraform provider that enables users to make custom API calls directly within their Terraform configurations, right? It's kind of right. If you look at what TerraCurl is from a high level, that's all it is, you know? It's, you declare a bunch of API instructions for what you want it to do, and it will do it as part of the runs, right? So let's go into a bit more detail for this, right? What we mean by declaring your API instructions is we have two types of calls. We have what I call managed calls. So essentially, the API instructions that you give as part of a managed call is going to manage this resource no differently to any other resource within Terraform. So if you have a network interface card or you have a cloud run or whatever it is that you're running, it'll be exactly the same thing, right? It will manage the lifecycle of this resource, right? Versus an unmanaged call, which is essentially a data source, right? So at the beginning of every single Terraform plan, it's going to make these API calls. So it's good when you need to fetch some data from an API in order to plug it into another resource for it to be created. Could be things like images or whatever it is you need, right? I've got someone who actually made a video about pulling YouTube analytics using TerraCurl, right? That's on YouTube at the moment. So yeah, you can pretty much do anything with it, but you have managed calls. So if you need to manage the lifecycle of the resource that TerraCurl is going to create, it's a managed call. And unmanaged calls is when you don't need to do that. You just need to make an API call, pull some data, right? So essentially it's a data source. Okay. So if we just kind of look at this, I hope you can all read that. because this is a slide, I will not be able to zoom that, but hopefully it's big enough. If we just kind of look at this, this is a high-level example of what a TerraCurl managed resource request looks like, right? So you can just imagine it's just like any other API call you make out there. It must have a HTTP method, right? Headers are optional, though most APIs that you probably would interact with will have some sort of authentication there, right? So headers is just sort of a map of key value pairs, right? So whatever headers you need, you can list it within there. Obviously, you need the endpoint, so the URL is what you'd pop in there. And an optional item you can add in there is a request body. So if you need to give it like a JSON payload or something like that, you can add that in there, whether it's directly using here doc, or you can use things like the JSON encode function, which we'll talk a little bit about later on. And then what you need to do is you need to tell TerraCurl what response codes you expect when this API call is made, right? And instead of giving it a single value, you can give it a list, right? Because especially when you're dealing with things like Vault, you'll make an API call and it will give you a series of different response codes. It will give you a 501, meaning that the server is not the leader, but it's healthy and it's up. Or it will give you a 200 because it's the leader and it's healthy. There's all these different things and you might find them acceptable. So you can give it a list of response codes. And that is the set of instructions that will create the resource, right? But equally, if you want to destroy those resources when you run a Terraform destroy, you need to give it the same set of instructions, but for destroy. And sometimes the API calls that you make for creation are not the same as the API calls that you make for deletion, right? So we don't make that assumption. We make you specify everything, right? So if you, and destroy is optional. Some people don't need destroy, which I kind of found that out the hard way. I used to require it in the early days of the provider, but I had a lot of issues raised on the GitHub repo saying, make it optional because of this use case, that use case. So it's now optional. Same sort of thing, just prepend it with destroy underscore and the same arguments as what you would have for create, right? And this will basically give you a managed resource, just like any other Terraform resource there. Unmanaged resource is a similar setup, except it's a data source, right? And because it's a data source, you're going to make this call every single time a plan or apply is run. So there's no such thing as destroy or any of those things there. This is going to happen every single time, right? So I don't really need to go over the items within here. It's exactly the same as what you've seen on the managed calls as well, with the exception of no destruction instructions. Okay, so we're going to have a look at a demo now, right? We're going to see TerraCurl in action, and I'm not going to lie, I'm a bit worried. The Wi-Fi has been, let's just say, not Wi-Fi-ing that well, but we'll see. I could do, but you know what? We're going to give you benefit of the doubt. We're going to see if this Wi-Fi can live up to the modern urban environments of TerraCurl, right? Okay, so like I said, I built this slide deck for a bunch of Microsoft engineers. So we're using Azure, and here is a resource group which I provisioned earlier on, and it literally has two things inside there. It has two virtual networks, and there's some peer in between them. And actually, what I should have done, forgive me, is shown you what the demo is about. So you probably can't read this, but this is a live open issue on the Azure RM GitHub repo at the moment. So what we're going to do is our demos, we're not just going to make any calls. We're actually going to take this issue and we're going to solve this person's problem with TerraCurl, right? So what they need is a data source which is going to give information about the virtual network peering state, right? So that doesn't exist at the moment. There's a PR open, but as of the time of writing this, and I think last time I checked, it hadn't been merged, right? So they need this thing here. So we're going to basically do some TerraCurl code to solve this problem here. And then that's for our unmanaged call. For our managed call, we have a different issue raised by someone else. And this one is an enhancement that they've requested. So the resource does exist. What they want to do is they want to create a Windows web app, but they want to have the ability to configure whether it's exposed to the public internet or not. Now, currently, this capability is hidden from the Terraform provider, but it's available to toggle on and off within the API, right? So we're going to solve their problem too. Okay, so we've seen this. This is what we're working with, and we'll have a very quick code walkthrough. So we're going to start with the virtual network. So most of you have written Terraform before, so you're quite familiar with specifying your providers and pinning versions and so on and so forth. I'm going to reiterate something right now. It's very important when you write Terraform to pin your versions, right? Especially with this that I'm showing you right now. That version 1.2.2 has been stable pretty much ever since it came out. But this week, I'm about to release version 2.0 of TerraCurl, and that will be breaking changes. So you're going to want to test that out in your environment. So if you are using TerraCurl, pin your version, please, because otherwise, if you just leave it to pull the latest, you're going to get breaking changes. Don't get me wrong, it's going to be fantastic stuff that comes in version 2, which we'll discuss later on. But it's going to break your infrastructure temporarily, and we don't want that, right? At least I don't want that for you. So yeah, so we have our Terraform required providers. TerraCurl itself, because we try to keep the API instructions so granular, we don't have any HTTP client configuration in the provider. Because if we do that, it means that every call that the provider makes is going to make it according to the same instructions. So people have really weird APIs. They'll have, like the create will require TLS, and the destruction will not require TLS. Don't ask me how this works, but there are crazy APIs out there. So if we put the client configuration at the provider level, that would cause those types of people problems. So we want it to be as granular and as flexible as possible. So there is no configuration at the provider level, right? Now, what we are doing is we are using TerraCurl alongside the Azure RM provider, right? So we do have the provider configuration there. This is not intended to be a Microsoft session, so I'm not really going to go through that. The point is you're going to see TerraCurl in action. It's going to work, right? So for this demo here, we are trying to get the peering state information as a data source from Azure. So as you saw on the screen earlier on, we have our virtual networks within a resource group. So we're just referencing a resource group using the data source, and we're referencing the two virtual networks, right? And then we get to the real crux of this demo here, which is the TerraCurl unmanaged request. Can everyone see that, or do I need to zoom the screen? All good? Fantastic. So in order to do this, these are the set of API instructions that are required, right? So it's a get call, which is obviously just grabbing information, right? You need to give each call like a name that it can use to store in Terraform's backend, right, in the workspace. So we're just calling this one demo peering state, right? Now, when you make this call, it should give a 200. Anything other than a 200, Terraform will fail, and that's what we want. We want to fail fast if something's wrong, right? Now, in order to make calls to Azure, you need to give it a bearer token, which I have some magic under the hood, which is going to inject that as a Terraform variable. And they need this header in there where the host is management.azure.com. Or I think you need it anyway, according to the documentation. Now, the endpoint that we need to hit is this very long Microsoft endpoint, which I've used Terraform interpolation to fill in some bits there and abouts. As you can see, this is what we're concerned with: virtual networks and virtual network peering, right? This is what the person needs. And what we're going to do is we are going to output the response of that into an output in Terraform, essentially. And you'll see in the next demo after this that once you get stuff in an output, you can do some manipulative things with it. So now what's going to happen is when we run this and it makes the API call, the payload that comes back, the response that comes back is going to be stored in your Terraform state. And that's good because then you can use those pieces of information to configure other resources or manipulate other things that you may need to do. So let's pray to the demo gods. And the language of prayer to the demo gods is applause when something works. Okay, let's go. So I've already initialized, so I'm going to run a quick plan. Actually, no, I'm not. What I'm going to do is I'm going to make sure that my token hasn't expired. There we go. We'll just log in. Okay. And it's number 3. Okay, and I'll just run a allow just to make sure that my bearer token's up to date. So that's cool, and then we'll just clear that screen. Okay, so demo time. We'll run a plan. See if this works. And the demo gods are thinking. And they're still thinking. And so far, they're being obedient. Though I think us should obey them, right? So we'll have a quick look at this. The actual apply is not going to be too much different because it's still making the API call. But essentially, let's see if I can find a piece of information they were looking for. Here we go. It's up here is the virtual network peerings, and you can see the 2 VNets, and this is the information about that peering there, right? So if we run a Terraform apply, I used to have an alias on my old laptop that was TF YOLO. It would literally just bomb the whole thing through without me having to put in yes. But saying the heads have prevailed. So it's the same thing that we saw before. If I hit yes, this should just write this to an output. Write this to an output. It has written it to an output, and all the information that they need is now stored in state, and it's surfaced via this output. Thank you, demo gods. I appreciate you. Right. Are we going to pray?
I assume we can write a jQuery to extract whatever from that.
Yes.
So assign to the output variable.
Absolutely.
Okay.
I will show you that in the next demo. There's built-in functions within Terra. I'll show you that in the next demo. That's fine. You will see that. Okay, cool. So we'll clear that. So that's the first demo out of the way, right? Now, second demo, let's just refresh our bearer token because I have a feeling on this terminal it may have expired. So on our second demo, they want to deploy a Windows web app, but they want the capability to decide whether it's exposed to the public internet or not. I have never used Windows web apps before on Azure. It's not something I intend to use, but if they deem that they need this feature, well, it's what they need, right? And hopefully the Microsoft team sees it the same way that they do. So configuration-wise, I'm not going to repeat the things that we've already gone through in the last demo. You know all the provider declarations and stuff like that. You've seen how we use the things side by side. But here, we're doing a few things, right? So the first step is we need to create an app service plan, right? To be able to configure the things that we need to do, right? So we're going to do this managed TerraCurl request, right? Again, give it a name, we give it the endpoint, the method is put. We've got a timeout on this. We haven't talked about timeouts. We'll talk a little bit about that shortly, but you can configure timeouts and retries as part of this as well, which is a really handy feature. We're giving it this request body, and we're giving it the headers. And I'm not really sure why this is like that. I'm not really sure why it's like that. But essentially, we want to, when it comes to the destroy call, we're going to want to skip any destroy calls here. And there's a reason for that. Do you remember those funky APIs I warned you about earlier on? It just turns out that Microsoft is one of those, right? So when we get to the next bit, you'll see. So here, web apps need to be globally unique within Azure, right? So if I give it a name and then I destroy and then there's some sort of race condition, I try to run the same demo again, it will fail because it already exists. So I'm just generating a random UUID that I can't remember if I prefix it or if I postfix it, but I'm basically using that to help me keep the name unique. And then we're going to create the second TerraCurl request, which is the actual web app itself. So this is it. So they wanted the public network access to be disabled. I think it's enabled by default, if I remember correctly, and they cannot configure that. So in this payload here, they can adjust that as they need, right? Which is the whole point of their feature request, right? And we give it the headers, the same as response codes, and again, a timeout. Because it's the Microsoft API, it can take some time when you make an API call for it to actually come back and say, hey, it's done, or actually that didn't work, right? It doesn't fail very fast. So we put that timeout in just to kind of buy us enough time to give it a chance to succeed. Now this one, we do want to put a set of destroy instructions in there, right? And I don't really need to discuss that in too much detail because you've already seen how destroy instructions work. Now, the reason why I didn't have destroy instructions on the app service plan is because the way that the API is constructed is you create an app service plan, web apps belong to an app service plan. When you delete the last remaining web app from an app service plan, it automatically deletes the app service plan. So when you put a set of destroy instructions inside there, it will fail your Terraform run because there is no app service plan to destroy. Once the web app is gone, the app service plan is gone as well. That's those funky APIs that I talked about, and there are many out there. So that's pretty much it. And then we are going to output our response again. And to your question earlier on about can you sort of grab pieces of the information, Terraform, as you may or may not know, has some built-in functions. And one of the functions is JSON decode, right? So essentially it's going to be a JSON response you get from an API. And we can use this function to pull pieces of information and route it as we need. So we just plugged it into this function here. And you'll see as part of this demo, we're only exposing the properties. And if that's sort of an object itself, you can go even layers deeper as well. You just do dot whatever the property is after that. So let's get into our second demo, right? So we'll run a plan. And hope that we did enough praying earlier on to keep the demo gods happy for this second ritual. And so far, so good. So if we have a look at this, it shows what it's going to do, right? So this is me exposing credentials. Love that. It will be deleted by the time I get in my Uber. And that's not me. HashiCorp has a very brilliant system for automatically deleting this stuff, right? So that's all the request information there, and it's going to create free resources, right? The free resources are the app service plan, the UUID, and the web app, right? So let's run and apply. And then what I'll do is when this is applied, we'll go to the website, refresh it, and we should see the resources are actually there, right? So I'll just hit yes on this because this is just a repeat of what we've already looked at. And this one does take a little bit longer, but it's not too long. Probably takes about a minute or so, this one. But yeah, so it's just going through. It's already created a UUID. It looks like it's created the app service plan. So the longest part of it is the actual web app itself. You know cloud providers, you know what they're like. How fast is GCP in provisioning?
Virtual machine?
Yeah.
2-3 minutes.
Oh, that's pretty good. This is quicker.
But of course, based on the OS.
It's true. It's true. So it's deployed, right? Before we head over to the website or the UI, this is the output. So the response that came back from the API is actually a lot bigger than this, but what we did is we zeroed in on the properties, right? And the properties has all of these different things in here. So if you needed something from here as a configuration parameter, maybe georegion or something like that, then you could put .georegion and it will expose just that by itself, right? So if we head back to our UI and I hit this refresh button, we should see some additional resources, and we do. We have our example app service plan here, and we have our Windows web app, which we've deployed to that app service plan. And I forgot I was actually coming to Sweden. I might have changed the region to somewhere a bit closer to here, and maybe it would have been even faster than your GCP, right? So if we head back to our terminal, this is the final bit of the demo. We've seen that it's actually created the resources. Let me run a Terraform destroy. And let's just hope that we did enough clapping in the first round, because all of you forgot to do your prayers a moment ago, that the demo gods show us mercy as we type this yes. And it should delete. Should be in the operative word. The question is, how quick would it be? Would it be GCP quick, or would it be Microsoft quick? We should open up a betting pool to see how long this will take. Oh. I think we should pray. Okay. So if I refresh this again, they should be gone. It should be back to just our original 2, which I needed that for the first demo. I didn't want to go through the headache of deploying VNets and peerings and stuff like that in front of you, because that takes 10 years. So let's head back to our slides. Okay. So I think I've talked a bit about some of the gotchas that you've seen already in this demo specifically. But one of the things that I've personally found as I use this is, if you don't express dependencies explicitly, the behaviors of APIs will not be taken into account, right? When you use a platform native provider, they know exactly how the API behaves. So the way that they build the workflows into how you use the provider, make sure that the built-in Terraform dependency graph is enough. You don't really need to use depends on meta argument. That's not true when you use TerraCurl. If something relies on TerraCurl, or if TerraCurl is relying on something else, express that explicitly. Do not leave it to chance, unless you understand the behavior of that API very intimately. Which leads me to the second point, which you saw an example of that, is understand the behavior of the API that you're trying to interact with, right? Understand what it would do in different scenarios. Any action that you want TerraCurl to take, understand how that API is going to respond to that and what it requires, and if there are any sort of gray areas that you need to cover. Now, what you've seen in this demo is what I like to call a hybrid approach. It was TerraCurl alongside the platform native provider, right? And that's perfectly fine. But there are times where that just won't work. And HashiCorp Vault is one of those things, right? I have a friend of mine who has basically built a Terraform module based on Kelsey Hightower's famous talk of running HashiCorp Vault as a Google Cloud Run container. He's basically modularized that, but he couldn't use the Vault provider alongside TerraCurl just because of some of the lazy instantiation issues that it was experiencing back then. So he went all in on TerraCurl, and it works really well. So just understand that that hybrid approach is preferred, but it's not always possible, and that's fine. Right? And more importantly, TerraCurl is designed to get you out of jail. It's not designed to replace the platform native providers. So if you don't have a problem with the platform native providers, do not use TerraCurl. we cannot provide the type of safety that they can, right? I'll say it again louder for those in the back of the room that might not have heard me. Platform native providers should always be preferred to TerraCurl. I love TerraCurl. It's one of my greatest creations. I've built a lot of things, and it's one of the things I'm most proud of, right? But it's not for every situation. Part of being an engineer is ascertaining what the problem is you're trying to solve and choosing the best tools for that, right? So we have to act like engineers and make the right choices, right? Now, the last time I checked, TerraCurl was at 1.7 million downloads, which is crazy to think little old me made something that many people need. It's only growing. It's getting probably about 35,000 downloads a week, which is insane. I didn't even know this until my manager kind of told me, hey, that thing you built is kind of buzzing around, right? If you want to learn more about it, TerraCurl.com will take you straight to the plugin registry, and it will take you directly to the page there. As I said, I'm hoping to release 2.0. There's actually a release candidate version out and it's been out for a while for testing. Because there's so many breaking changes, I kind of didn't do my YOLO thing. I put it out there for people to try out first. But some of the new things that are coming in version 2 is everyone familiar with ephemeral resources that was recently released in Terraform? Yep, okay. I'm not seeing the enthusiasm other than from my compadre over there. So I'll just quickly have a quick rundown of ephemeral resources. So sometimes when you configure a resource, it has something sensitive about it that you don't want written in the state file. So historically, the advice has been, well, make sure your state file is encrypted, right? But reality of the situation is that's not enough for a lot of big enterprises. So the idea behind ephemeral resources is that it will not store these things within the state file. So it will provision the resource. It will take the sensitive value from that response that you need, and you can plug it into one of a couple of objects. One of them being is the provider. So if you, I don't know, provisioned a database and it spits out like a database password and you had some other provider that configures the database, then you can basically take the output of that and put it into the provider, but we will not write it into the state file as well, right? And kind of related to that is write-only attributes. So some providers have implemented that where, let's just say you have a password attribute that you need to specify when you're provisioning a resource. Instead of it being written to state, it will just provision it with that write-only resource and not write it to state as well. But the rest of the resource will be in state. So ephemeral resource is introduced, and we also have drift detection as well. Currently, what happens is when you apply this resource and you run another apply, it will look at the state file and it will compare it to your Terraform code. And if there's been no change in that, then no changes to infrastructure. With drift detection, it will actually make a call to your platform, Azure in this case, and it will say, here's what's in the state file, here's the desired state. What's your actual state in the cloud, right? And if any of that is different, then it will take the corrective action to put it into your desired state. So drift detection is another thing that's coming out. And in order to enable all of this, I'm not sure if you're aware that the SDKs that power Terraform providers went through a big rework a while ago. So it was the Terraform plugin framework is the new thing that they've come out with. So all the new features are being built on top of that. So I had to do a complete rewrite of TerraCurl to bring you some of these nice features. So that's all coming. I have some big ideas for 2.1 as well, but we want to get 2.0 out first. We have a Discord community. It's very small at the moment, but these people are passionate about TerraCurl. If you want to join it, the link is there. Feel free to jump in the community, ask questions, help people out, whatever it is. But that's what I wanted to show you today, and I really, really hope that if you run into problems out there, that this will save you. I've had countless messages from strangers thanking me for building this because it saved their job or it got them out of this tight hole, and honestly, it's humbling. So thank you so much for listening. I won't take up any more of your time, and I'm open for questions.